turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
Hello and welcome to The Naked Scientists, a show where we bring you the latest breakthroughs in science, technology and medicine. I'm Harry Lewis. This week, scientists reveal how many people are suffering from long COVID, cooling nerves to treat chronic pain and mapping the entire ocean. And a little later... You better get out of the pond, Luce.
I'm stuck.
Yeah, we're going to be getting literally stuck into a ghostly pond hunt, bringing long-lost bodies of water back from the dead.
The Naked Scientists podcast is powered by ukfast.co.uk.
But first, infection with the mosquito-borne disease dengue or its relative, the Zika virus, alters a person's smell, makes them more attractive to mosquitoes, boosting the spread of the disease, a new study has found. The Chinese-based team have shown that when mice pick up a dengue or Zika infection, the viruses temporarily alter their immune systems so that the spectrum of bacteria growing on the skin changes, altering the body odour. The change boosts the output of chemicals that mosquitoes use as a signal to find their next meal. Leslie Vosshall works on mosquito attraction at the Rockefeller University in New York. She gave Chris Smith her opinion on the new paper.
What they show, which is what we have been looking for in our field for centuries, is an explanation for how viruses manipulate mosquitoes and humans to make it easier for mosquitoes to find humans. They infect mice with Zika or dengue and show that the virus changes the composition of the skin bacteria to make those animals much more attractive to mosquitoes. And so in a way, the virus is changing the composition of the body odor to lure mosquitoes, which makes it easier then for the virus to hop between mosquitoes and an animal host. And so this has huge implications for how viruses move back and forth between people and mosquitoes, and provides a sort of an entry point to figure out how can we make this not happen.
How does the virus do that? How does it actually change the composition of the microbiome? What's going on?
The virus has figured out how to interfere with the warfare between the microbiome and the human skin. What they're doing is manipulating this antimicrobial that would normally sort of prune back the garden of bacteria. And then as a result, you get this huge increase in the microbiome, and then the microbiome can increase the overall smelliness of the host.
And it's the smelliness that then attracts the mosquito.
What they say is exactly that the virus playing with the composition of the skin microbiome is vastly increasing the smell. What I find remarkable is that it comes down to a single molecule. So you increase the amounts of acetophenone from the skin, and then that by itself is able to increase attraction.
Do we see other infections doing a similar sort of thing, or is this the first time we've really got a handle on how diseases can manipulate the way we smell and therefore our attractiveness to biting insects?
What's amazing about the paper is that they didn't just leave it at dengue. They also showed that the same mechanism is happening for Zika, which is great. So sort of double their work and double the impact. So there are many other RNA viruses that infect Aedes mosquitoes, and they haven't studied those here. It would be interesting to see if chikungunya or yellow fever has this effect. Sort of going off of your question, there's a little bit of data showing that people who are infected with malaria pathogens become much more attractive to mosquitoes.
And now we know that this happens. Can we come in at the other end of the argument and say, well, we know this is happening, it's making the mosquitoes want to bite people. Do we understand how it does that to the mosquito? And are there prospects for being able to intervene in that process to stop mosquitoes being attracted by these substances and therefore break chains of transmission of these diseases?
Mm-hmm. Right. So first of all, this paper is a tour de force of biology. What everybody wants to know is, okay, this is fine, it's a great paper. How do I prevent from getting bitten? I don't want to get bitten by mosquitoes. And so there is a bit of a message of hope in this paper. So, and the logical chain would be as follows. So acetophenone makes us more attractive to mosquitoes. The mechanism in the mosquito is that they pay attention to human body odor. They use that information to hunt. And so if acetophenone is a major signal that lures mosquitoes to us, What they say in the paper is, of course, if you manipulate the skin microbiome, to produce less acetophenone, you should be less hunted by mosquitoes. And so, one possible application is that we have mechanisms, skin creams that will reduce the colonization of bacteria that produce acetophenone, for instance. So it's difficult to manipulate the biology of the mosquito to change how they think about us. It's much easier to manipulate our skin, to make us less smelly in ways that would attract mosquitoes to us.
Leslie Vosshall commenting on a recent paper by Gong Cheng from Tsinghua University in China and published this week in the journal Cell. Now, though, to space. There's a few things to be excited about if you're a keen astronomer at the moment, like me. We're only days away from the first pictures of the James Webb Telescope. There's an update regarding Voyager 1 and 2, as well as a mystery to solve on the far side of the moon. There you go, Pink Floyd, eat your heart out. For this celestial roundup, James Titko spoke with space science journalist Richard Hollingham of the Space Buffins podcast.
So, Richard, the time is almost upon us. We'll be seeing the first images from the James Webb Telescope later this month. If the rumours are to be believed, they're going to be something really special. How excited should we be to finally be at this point?
We should be extremely excited. 10 years ago, they started work on this and building it. In fact, more than 10 years ago. There were 344 single-point failures on this mission. So many things that could have gone wrong. But now, there it is, sitting 1.5 million kilometres from Earth, looking out into space. We know the mirrors are aligned. We know it all works. We know it's sending back data. There are almost certainly those images sitting somewhere being worked on right now. They wouldn't have hyped this and hyped this date and hyped this release if they didn't know it was all going to work. I think the bigger point, though, is that the James Webb Space Telescope is really a step change in what we can see. It's the biggest observatory ever launched in space, 18 mirror segments, 6.5 metres across. But it won't be giving us the visible universe like Hubble does, which is what we would see if we had really, really good eyes. It will be giving what one scientist I spoke to suggested was a snake's eye view of the universe, which it will really be seeing in infrared. I mean, infrared we can take as heat. So it will be able to see through a lot of things that currently block our view. And because it's so much bigger collecting area, it'll be able to collect photons pretty much, not quite, but pretty much from the dawn of time. And also give us a sense of atmospheres, perhaps around distant planets, distant worlds. I mean, we don't actually know what it'll be able to do. Same with Hubble, really. They didn't really know its capabilities until they stuck it up there and started saying, wow, we can see this, we can see this.
There's also been some news circulating that Voyager 1 and 2, the twin space probes which left Earth nearly 5 decades ago, are potentially powering down. Is there some truth to this?
I think powering down's the wrong word. They are gradually running out of energy. So they have these nuclear batteries on board, essentially generating heat from radioactive sources, converting that into electricity. That's decaying. So they are running out of power. But I just thought I would check. I mean, where better to check than actually from the spacecraft itself? The spacecraft tweets and it actually says, while our power budgets will continue to get tighter, our team thinks we can continue to do science for at least another 5 years. I might get to celebrate my 50th launch anniversary or even operate into the 2030s. So there you go. That's from that's actually from the NASA Voyager spacecraft. I mean, the reality is they are still sending back data, not a huge amount. There are not that many instruments working on them. I don't quite understand why this story has come up now. There's been a bit of a data glitch with one of them, but these things happen all the time with spacecraft, and they're just trying to make sense of that. And even beyond that, once they do finally die, and they will finally die because they will run out of power, they're still really our ambassadors to the stars because they've got these information about Earth and where we are all attached to the side and these golden records. So Voyager 1 and Voyager 2 will exist, well, long beyond us.
And finally, Richard, there's something of a mystery to be solved when it comes to 2 craters which have appeared on the far side of the moon. Now, we know they've been formed by the discarded stage of a rocket, but it's not clear which. Is there any update on this?
This is a really interesting story, isn't it? So 2 new craters. They know now that they were formed on the 4th of March. The initial thinking was they were formed from a discarded SpaceX rocket. That's been dismissed. They're likely to be, but there's been no confirmation of this, from a Chinese rocket stage, a rocket that flew past the moon. And this is all part of the sort of international ambition to go back to the moon.
Does it make you a bit sad, potentially, to reflect on the footprint we're leaving up there? It's not enough for us to just be polluting Earth. We've got to ruin parts of the moon as well.
Yeah, well, we're trashing the Earth. We've managed to put a huge amount of space debris around the Earth, and now we're leaving it on the moon. I mean, I think you have to think, well, the moon's pretty big. It can take it. I think the bigger concern will be actually when we start going to Mars, because, you know, there's no life on the moon. We know there's no life on the moon. But there's the potential for finding life or the signs of life on Mars. And if we keep sticking stuff there's the chance that actually that life might have been brought by us from Earth. I think we've got to be really careful when we're going to these pristine bodies that we're not contaminating them and not polluting them.
I don't know about you, but I remember being sat over Christmas watching the James Webb Telescope launch. So the thought of seeing the fruits of that labour are quite exciting. That was Richard Hollingham speaking with James Titko.
From baffling British weather
sideways spines of the vertebrae coming off here
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists In Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials on iTunes.
You're listening to The Naked Scientist. Still to come, how researchers are mapping the entire ocean sea floor using cooling technologies to treat chronic pain, and ponds that have been filled in across the globe. Now though, as coronavirus infections surge once again, we think somewhere between 1 and 2 million cases are occurring around the country every week at the moment. Conversations are frequently turning to the question of long COVID. It was quite soon after the pandemic began that significant numbers of people reported symptoms. They seemed to persist long after the virus or infection had gone away. This is where the name long COVID came from. So how many people have been affected, and for how long, and who is most at risk? Well, Ellen Thompson at King's College London has found the main risk factors, and she suggests that the number might sit somewhere between around 17% of those people that contract the disease. If you drill down a bit further to pull out those cases for whom long COVID has a major impact on the quality of life, it's still about 5% of people. It's quite a startling figure.
This paper aimed to look at the frequency of long COVID within the population and the risk factors. So we looked across a number of health and demographic risk factors for long COVID based on data that was collected between 2020 and 2021. So it doesn't incorporate the new variant of COVID-19 called Omicron, but we do now have new data. So researchers are starting to look at the impact of the different variants on things like long COVID.
And to be included in your study, what did a person have to do? Did they just have to test positive for COVID? How was it that you gathered the individuals you looked at?
The data sets we used were population already established data sets. So what we have in the UK is we have a number of longitudinal studies that track people over time. So we use data from those studies, and we also use data from anonymised electronic health records.
And what actually emerged when you look at the rates of people getting some kind of post-viral syndrome? How many get it?
Around 17% of individuals experience long COVID for more than 12 weeks. But I think what's important to say is that within our data, we looked at functionally debilitating symptoms, those that impact everyday life. We only found that around 5% of people experience those symptoms.
Do people actually really agree what symptoms constitute long COVID? Are we really comparing apples with apples? Because when you talk to some people, they'll say one thing and others will say another, but they're all being united under this umbrella long COVID. So do we really, as a scientific community, have some kind of consistent definition now?
Currently, the definition of long COVID does include a whole range of symptoms that people can experience. But within that, the most common types of symptoms are fatigue, loss of sense of smell, loss of sense of taste, as well as a cough, and sometimes sort of confusion or memory loss within that. So although there's a whole host of symptoms that people can experience, they're the most common type that have been seen within the data.
Did you, though, consider the general population who didn't have COVID at the same time? Because the Office for National Statistics have at certain points published numbers suggesting that when they looked at people who had long COVID symptoms and no diagnosis of COVID, the numbers were a bit similar, suggesting that perhaps what we're calling long COVID reflects real life for some people.
Yeah, great question. So within our study, we were focusing on people who had COVID. So in order to be sort of included in the analyses, we only based it on those who had COVID as a precursor of long COVID. However, we did use some statistical techniques in order to account for the probability of getting COVID. So we feel relatively confident within a certain degree of certainty that we're sort of showing that long COVID is an outcome for people that do have COVID, and there are certain risk factors for getting long COVID.
And what are they?
Female sex, increased age, overweight and obesity, and underlying health problems or pre-existing health problems were predictors of long COVID within our data.
And did you look longer term, beyond the 4 weeks, or some people using 3 months as a definition of long COVID, aren't they? But if we go out longer, is there sort of good news for people who might find themselves in this position? Things are going to get better.
We did look at both 4 weeks and 12 weeks. We don't have the data yet to look longer. Well, I should say we do now, and that's exactly what we're doing. So we're currently planning a study on looking at recovery of long COVID, as well as sort of longer term symptoms.
But does it look like people can look forward to feeling better in the future, or are there people condemned to stay long COVID positive indefinitely?
Yeah, we hope so. There is evidence coming out that suggests that symptoms do subside after a certain amount of time in most cases. I think what will be important is to think about why and for whom symptoms are continuing for longer, as well as think about predictors of recovery. So what's really helping people kind of recover from long COVID.
And to what extent is this exclusive to coronavirus infection? And to what extent do you see the same sort of manifestation in the aftermath of a bad flu?
Yeah, that's a good point. So when we're talking about long COVID, we are specifically talking about an outcome of COVID-19, but we do know that post-viral fatigue, for example, does exist with other infections. However, we think it's important to think about long COVID because of how common COVID-19 is and the fact that it's a global pandemic. We need to think carefully about this.
Thought-provoking stuff there. That was Ellen Thompson speaking with Chris Smith, and her study has just been published in the journal Nature Communications. Now, the way we tend to manage pain is by giving people pills to take. Quite simple, really, isn't it? And it's often an excellent strategy in the short term. But for people with chronic pain conditions, it's often less ideal. Drugs all have side effects, of course, and they're more often likely to manifest the longer a drug is used. So is there a better way? Well, as he explains to Julia Ravey, Northwestern University's John Rogers thinks so, with an implantable device that harmlessly cools down nerves in the painful area, numbing the discomfort.
It's a pretty basic effect, actually. Anybody who's been out in cold weather and you have your hands exposed to cold, you will notice your fingertips become numb. You lose a tactile sensation. And so the idea is to just exploit that basic effect, but allow that cooling to be delivered in a targeted way to nerves that are deep in the body, not just those that are near the surface of the skin and the fingers, and to target those nerves that are carrying pain signals relevant to a specific patient condition. And so what we've been able to do is to create a soft cuff type structure that encircles a targeted region of a particular peripheral nerve. And the consequence of the reduced temperatures that follow from the action of that device is that you literally just block the ability of those pain signals to pass through that region of the peripheral nerve, and you can create this numbing effect.
How did you test if these devices are effective at providing pain relief?
Ultimately, in order to show the ability of the devices to work in the targeted manner, we need to do animal model experiments. And so we've used rodent models, rat models, for those in vivo studies. And we can test the magnitude. We're numbing the paws by poking the base of the paw with a fine filament, not one that penetrates the skin or creates any intense sense of pain, but one that does create a sensory response in the absence of cooling. And that sensory response causes the animal to retract the paw away from the filament. And as we dial up the cooling power, we have to push harder and harder in order to cause the rat to sense that pressure and to retract the paw. And so with the cooling, we can increase that pressure threshold for retraction by about a factor of 10.
Are the materials they're made of, does that mean that they would have to be removed in the future, or can we just leave them in the body? What happens once they're in?
All of the constituent materials are naturally bioresorbable. So they dissolve and melt away in the body. In some ways, they're conceptually similar to a resorbable suture in the sense that the device is present when it's needed, but it's engineered to naturally disappear after that pain medication is no longer necessary. And that's an essential aspect of the engineering, because if the device were not resorbable, then one would require a secondary surgical extraction procedure to remove the device after it's no longer needed. And that kind of surgery is highly risky because disentangling the device from the targeted region of the nerve, especially after scar tissue has developed, could be very tricky. Without it, it would be hard to justify a device of this type.
John Rogers from Northwestern University there on that work published this week in Science. He was speaking to Julia Ravey. Now, at the first UN Ocean Conference only 5 years ago, an ambitious target was proposed to map the entire seabed by 2030. Today, just shy of 25% has been accumulated and uploaded for all to see. Last year alone, some 10 million square kilometres were added, and that's the equivalent to the land surface of Europe. Here to tell us more about the project is Jamie McMichael-Phillips from Seabed 2030, a collaborative project providing the inspiration and thrust needed to get this target over the finishing line. Why have we set such a difficult challenge?
We cannot manage what we haven't mapped. We have an Earth surface of about 510 million square kilometres. 70% of that is covered in ocean. And to date, we know more about the surface of the moon. We know more about the surface of Mars than we do our own planet. So we need to get out and map our ocean floor because of a whole host of other science and activities that are hugely dependent on having an accurate map of the ocean. So, for example, to be able to manage our fisheries, to be able to manage ecosystems and to protect ecosystems, we need an adequate map. The ocean is full of bodies of water of different densities and different temperatures, and they mix throughout the ocean, driven by the ocean currents, and those ocean currents are influenced by the shape and the roughness, the ruggedness of the sea floor. And those ocean currents have a direct effect on climate change. They interact in our polar ice cap. They have an effect on the climate. They have effect on sea level rise. And it's hugely important we get out there and we map our ocean floor. 25% to date. We need to get to 100 by the year 2030.
That's really interesting. I didn't realise quite how obvious the relationship is between the sea floor and ocean currents as well, which in the future with climate change on the rise is going to be of paramount importance, being able to predict that movement. I guess when it comes to looking at mapping the seafloor, my initial thought was, can't you just slap a lot of scientific instruments on merchant vessels? But on a second count of it, I guess those paths that they take, they're quite strict. They have to stick to certain routes. So maybe it's probably not the best thing to do. Where are you getting this data from, or where do you go to get the rest of this information?
Well, the biggest challenge, Harry, is that we are stuck with using sound in water to measure water depth. We've heard before about the Hubble telescope, the James Webb Space Telescope. Everything that operates in the visual spectrum doesn't apply in the oceans. Light only penetrates no more than about 10 meters of water. So we've got to use sound. And we do that using a sonar system, a ping from the hull of a ship, measure the two-way depth, and you can measure the two-way return, and you can calculate the depth. And it's a long, slow process because we do have 362 million square kilometers of ocean. So getting out there and gathering that information is a slow process. We're hugely reliant on data donations from government ships, from philanthropists, from industry, and from academia. But also, very crucially, and this goes back to the very heart of our inspiration, every vessel operator has a potential to become a scientist, a citizen scientist, by logging the depth information from their safety of navigation echo sounders, logging the position from their GPS systems and sending it into us. And every piece of depth information adds to that map.
I guess as well, Jamie, there have got to be some points. The ocean's so vast, there have got to be some points where vessels just don't normally go. So you're really having to call upon these people, aren't you?
Absolutely. There are vast swathes of ocean. I mean, you've said earlier, 25% mapped, 75% still to go. And there are parts of the ocean that are off the beaten track. People simply don't go there. And we need to mobilize our global community to think about those areas, because the ocean is joined up. It is one ocean, and therefore we cannot afford to miss any part of that ocean space out. We've got to get out there. We've got to map it. And this was, I think, something that we have been doing since 1903. It was an initiative that was started by Prince Albert I of Monaco, and he brought together scientists, engineers, oceanographers to try and mobilize that global community to start mapping the ocean. And Seabed 2030, established in 2017, we're now in year 5, has been the accelerator to get from where we were in 2016, which was 2017, I should say, which was at 6%, now to just under 25% of the world's ocean floor mapped. But we've still got a long way to go, and we are on target, but we've got to focus the global effort to get there by 2030.
And have you, so far from the data that you have collected, has anything stood out as unusual, or have there been any particular highlights?
Oh, well, absolutely. And if we go back to October 2020, one of our research partners, the Schmidt Ocean Institute, had a team of scientists on board their research vessel Falkor, and that team was led by the James Cook University in Australia, and they discovered a 500-meter high detached coral reef in the Great Barrier Reef area, the first time that such a feature had been discovered in over 120 years, and that was 5 times taller than Big Ben, taller than the Empire State Building, and nobody had discovered it until October 2020. And more recently, in January this year, a huge pristine coral reef was discovered off the coast of Tahiti. And all those discoveries need to be based on looking at what's on the map, looking what stands out as unusual. And of course, if we haven't mapped it, we cannot detect those features.
And if you can't detect them, I guess as well, you can't protect them. Jamie, thanks ever so much. If you're listening in and you're a certified captain of the open seas and think you can lend a hand, a reminder that was Jamie McMichael Phillips from Seabed 2030. By the sound of it, he'd sure love to hear from you.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientist with me, Harry Lewis. For the rest of the programme, we're talking ponds. Across the world, we are losing valuable wildlife habitats, some of which, once upon a time, thrived in coexistence with human activities. I found out, whilst nestled into my sofa, chatting over a nice warm mug of tea with a close friend, that there are really ambitious attempts being made to try and bring ponds back from this death. You'll find out that this saying is quite literally true later on in the show. In the UK, a scheme has been set up to try and help them, forming the district-level licensing for great crested newts in particular. It consists of multiple contributors, one of which we're going to go and join. So grab your wellies, put them on if you will, and let's venture out on a pond hunt to hear what's happened to them, why they're important, and how we can all help with their reanimation.
There's no plant life here yet, but there are quite a few invertebrates using the pond already. Oh, and look over there. There, obviously birds have been down to visit and drink. Their prints are in the mud. Yeah, it's looking brilliant.
This is Lucy Jenkins and her British setter Wally. She's a farm environment advisor at Farming and Wildlife Advisory Group East, or FWAG as it's better known. But for the most part, she works on the UK's pond project in association with Natural England.
Well, the UK has lost 50% of its ponds over the last century. So that's 500,000 ponds lost in the UK over the last 100 years.
Why is that?
Well, they've been lost for a number of reasons. The intensification of agriculture. Ponds used to be an essential part of sort of activities on the farm. You know, they used to be used for livestock watering, whereas now livestock troughs will be used instead, drinking troughs. Ponds would have been dug for marl pits, marl was used as the soil conditioner. Obviously those kind of activities don't go on anymore, so you don't have the same kind of creative pond forces at play.
That's interesting that you're saying that this ecosystem was in harmony with our old agricultural practices.
Yeah, absolutely. Having a source of clean, fresh water on the farm was absolutely essential in a way that is less so now.
You're putting these ponds back in with FWAG. What is the work that you do specifically? What do those projects entail?
Yeah, the main pond project that we're working on at the moment is a pond creation and restoration project for great crested newts. So we're digging new ponds and we're restoring dilapidated ponds to provide better habitat for great crested newts.
When I think of a pond, I think of koi fish down the end of the garden. But what actually is a pond, Lucy?
If I was being really technical, a limnologist would say the difference between a pond and a lake is that sunlight can reach the bottom of a pond. It can't reach the bottom of a lake because a lake is so deep. So there is an area at the bottom of a lake which doesn't get sunlight.
We're going to go off and follow you now. Everybody's coming along on a little tour to see what exactly it is that you get up to and how you manage to improve the ecosystems that are surrounding us from the day to day. Who's up first?
First port of call is Dan's place, visiting a site that has potential for pond creation for great crested newts. So we're going to go and check that out. It's just down the road.
You better get out of the pond, Luce.
I'm stuck. Please don't put that in.
I'm stuck. Great crested newts have suffered huge population declines, but ponds support other life. In fact, 2/3 of all freshwater species can reside there. Rare creatures like fairy shrimp and amphibians suffer in population declines as well, including your common frog or toad. They can harbour more invertebrates than rivers, not to mention the mammals, birds and bats that all love the water, especially in the summer, and insect chimneys that rise up from them. Ponds can even act as carbon reservoirs and can mitigate flooding. So once we manage to get Lucy and wrestle her out of that pond, we're off to see Dan Lister in Winwick, close to Huntingdon. Although maybe Dan had been working a little bit too hard because he couldn't seem to quite recall where he was.
What do you mean, where are we? Big question.
It's your farm, Dan.
Right. We're in a dog leg of a field that tends to sit very wet, so it's not a particularly productive agricultural site. And I've offered it up to Lucy here that if she wants a newt project, it's an ideal space for it.
Lucy, first impressions on arriving?
So this looks absolutely perfect for the Newt Ponds project, really. There's really good connectivity around the site. There's really mature, dense, bushy hedgerows that mean the newts have sort of dispersing habitat, so they can get away from the site, they can get to the site. The habitat that we're standing in is a mix of fine grasses and wildflowers, mainly oxeye daisy. So again, that's sort of perfect foraging habitat for the newts to be preying on things like beetles, slugs, snails when they're in their terrestrial phase.
And is this sort of how the process normally works? Would you meet up with the landowner, and then the landowner points out where they think the pond should go. But if you're the specialist, shouldn't you be coming to the land and pointing at which part that you want to put the pond into?
Absolutely not. They'll know where it sits wet. They know where the soil is clay, will hold water. The farmer has inspiration for where might be a good place for a pond.
And what's the next step?
From here?
Yeah.
Well, I'll go away back to my desk and come up with some draft pond designs that I'll send over to Dan, and then he can comment on them. We can change them around, we can change the sizes, shapes, and then we go from there, really.
And so looking at this plot of land, what will you be advising to Dan? What does the future of this landscape look like?
Ideally, having sort of multiple ponds is much more valuable to wildlife than one large one. So the reason for that is if one pond becomes polluted, or it gets high nutrient levels in from runoff, or it gets fish in, the newts have other ponds to get to. Equally, if one of the ponds dries in a summer, they've got other ponds that they can make use of in the local area, in the very nearby local area.
Lucy's just mentioned surface runoff, and I guess that comes down to the chemicals that you're using on your farm. Is that something that we do need to be aware of?
Every farmer does their very best to minimise that kind of thing, but there is always a chance of it. The seam we're looking at now, we've got about 200 yards before there's an actual arable crop. So there's a really good buffer. It's very, very unlikely there should be any chemical contamination of where we are now.
We were speaking on the way down when the mic wasn't on, and I said I thought this whole operation is really interesting because normally there's a conflict between conservationists and farmers. And you laughed at me. Why were you laughing?
Well, there shouldn't actually be a conflict. Very, very few farmers aren't interested in conversation. Basically, they're busy. They are working 7 days a week, 12, 14 hours a day. All farmers actually love the environment they're in. That's why they're doing the job.
And do you think that public perception, what I've just said, do you think that's a common theme?
Oh, yeah. I think the general public has a view that farmers are spreading chemicals around the countryside willy-nilly that isn't actually necessary. Farmers don't like using chemicals at all. In fact, a lot of the things that we apply to the crop is just to meet the rules of various schemes that we're in.
We leave the marshy farmland and walk adjacent to the hillside that Dan's father replanted with trees. Dan says it's his turn to give something back. So after their 5-minute chat, it's all decided. Lucy's going to tackle the paperwork and forward over some drawings, and Dan will dig the actual site. It's as simple as that. Lucy has a number of sites where she's already restored or created new ponds, and its success is definitely a testament to dedicated and enthusiastic landowners, because trying to bring back biodiversity to working land isn't easy, as you're going to hear at our next stop in Ware with Nicholas and Henrietta Buxton.
I just went round the farm and we wrote a list of about 30 odd ponds, from existing ponds to scrapes to the old slurry lagoon to where we thought we might like to have a pond as well. Then I rang up Lucy and said, what can we do? Can FWAG help? And she came along, and from there it's just been, well, I've been very excited. She found some funding and we did 10 last year and hoping to do another 6 or 7 this year.
And have you both seen an improvement in such a short space of time? Have you seen the benefits of putting these bodies of water in?
I think it's early days, but we've been involved in stewardship for a number of years and making connections within the landscape. So we're joining up bodies of water with hedgerows and stewardship strips of grass margins and flowers. So really reconnecting the landscape, and water was something that was missing, and we've been able to do that.
Do those benefits come in any form to the value, not just in biodiversity, but perhaps economic value?
In truth, I don't think there is. I think this is something that we both feel passionately about, we're involved with, we want to invest in, and more the stewardship agreements are oriented towards celebrating what we have, enhancing things and looking after the trees and the hedgerows and planting, which is a sea change from where farming was 30 or 40 years ago. And I think it's just a part of the landscape that for lots of reasons has been lost and overlooked, and now we're able to bring it back to life.
Could I ask you about the subsidies? Could I say, I don't know if I could ask how much. Can I ask how much?
I haven't got an answer for you, because there is the BPS, the Basic Payment Scheme, is going away, and that is a serious challenge for this farm and for all farms.
What is that, sorry?
The basic payment scheme is an area-based payment for which the industry has grown used to and is being taken away, and so what was a significant element of our income is being reduced, and therefore we're looking for opportunities to replace that, which leads me into stewardship generally. So these are important cash flow contributions.
Would you expect those subsidies to provide a form of income? Will they, if they don't provide a form of income, will they pay for the project in its entirety, or do you still need to front some cost when pursuing this relationship with nature?
We will apply the monies that we receive, and we will not make money. So to that extent, it's a luxury, but I believe it's a very important part of what farming can do for the future. To retain that connection with people that enjoy this landscape, we have to try.
After excavation only a few months ago, this pond is still recovering. It was once neglected and rank, but now grass shoots are reaching skywards from the muddy tractor marks, and life is beginning to flourish once again. And there's a lot going on at this site. As part of the monitoring process, Ginny from FWAG is collecting water eDNA samples and looking for signs of the great crested newt. This will be done over varying timeframes for the next 25 years to collect data and better inform the project in the future.
So we take 20 samples from around the margins of the pond. They all go into a test tube which gets sent to a lab to establish if great crested newts are using the pond already or if they're yet to find it.
Will you get evidence back of just the newts, or will you find out everything else that's in here as well?
No, they're just looking for great crested newt DNA.
How long will that take to get back?
We get the results in August.
Oh, quite a wait.
Yes, yeah. Well, yes, because we're testing all of the ponds that have been established so far under the scheme nationally. So the lab's going to be kept quite busy this summer, I think.
900 samples will be sent off this year in the UK alone. But it's not just Ginny here with her eDNA samples. Adjacent to us is also Steve Brooks, a former Natural History Museum entomologist, who now oversees the Riverfly Monitoring Initiative. And he has come properly kitted up. You've got your net right here. Do you think we can have a little go and see what we can pull up?
Yeah, let's try that. I'll just put some water in this tray so we can see what's in the net.
It's quite a professional looking net as well, this, Steve.
Yeah, these are expensive bits of kit actually. Set you back about £80.
And not to be lost when you're out foraging.
Exactly. So I've just trawled that through the open water really. So we can see lots of toad tadpoles here, the jet black tadpoles. Frog tadpoles are speckly, but toad tadpoles are jet black. We can see pond olive, mayfly. We can see a lot of nymphs of water boatmen. We can see beetle larvae. There's a diving beetle larva.
And this is all made easier in our white tray here.
Indeed.
It's absolutely teeming, because I've done a little bit of this myself, and I don't think I've actually seen quite as much as we're seeing here.
No, I mean, there's a water mite. You can see there's a lot of stuff here, and it's typical of things you'd expect in an open water habitat, and it will get more diverse as the plants start to develop in the pond now that the light's been let into the pond. Ponds are best for biodiversity when they're open because it lets the light into the pond, plants develop, and that attracts a lot of other organisms. So when the ponds have been neglected for decades, they basically turn into small spinneys, and they're not really very good for anything.
As I was leaving, Henrietta regaled this tale of their latest project, how they found the remnants of an old pond, and upon digging, a fountain just erupted, filling the excavation naturally. We'll be going on a ghost pond hunt of our own very shortly, in fact just after this. It's not to be missed. Now, we've heard how conservationists across the UK over the past decade have assessed the risk of pond habitats throughout the land and begun taking evasive measures to restore them. They're hotspots for rare plants that in turn draw in rare insects, which again then attract bats, birds, and in the long run, mammals. It's a true plethora of life that just reap the benefits of fresh water. But digging out new ditches is work intensive, and Henrietta's ghost pond has me thinking there might be an easier way. As you can probably hear, I'm on the road leaving Lucy for a while and heading back to Bowdham in North Norfolk to catch up with Carl Sayer. He's leading the one-of-a-kind pond restoration research group at UCL and also heading up the Norfolk Ponds project that's been alive since 2014. This falls into the same scheme that Lucy is delivering on. Norfolk actually holds more ponds than anywhere else in the UK, so if anyone is going to be the spectral pond reverend, it'll probably be Carl.
Hiya Harry, you ready?
Yeah, where are we going?
There's 2 ponds, a couple hundred metres over there. Short distance. Yeah, all well spotted. Absolutely well. So you have just seen the first.
There's another one there.
Well, presumably hatched out of this pond, because that's a froglet, isn't it? That's a this year's hatchling.
Oh, there's a few.
Well done.
1, 2,
yes,
3.
There is. So how did we miss that? We're actually standing amongst frogs, and they've come from there. They've come from there. So that pond has already done frogs. We've got. There's not just one, is there? There's. Are we talking hundreds?
Yeah, I
Probably.
think so.
If you start looking around, don't move.
Whereas on the Buxton's farm the ponds were muddied with sediment on account of their recent renovation, the bodies of water here amongst the wildflower meadow are beautiful shades of turquoise, almost like that of the Mediterranean Sea. You'd be able to see straight through to the bed if it wasn't for all the plant life that has taken root.
We are looking at 2 little lenses of water in the ground that are ghost ponds. And you need to know what that is. So a ghost pond is a pond that was lost from the landscape some time ago. And what you do is you resurrect that ghost pond by digging it out. So you never totally lose them. They're represented by little puddles in the fields and damp patches. And if the farmer will let you do it, you can dig them out and up will come the water and you'll get a pond again.
I mean, we've got one of them right in front of us. Can we just pop down slightly closer and have a look?
Yeah, come on, let's have a look, yeah. So you're going over lots of spoil and earth and all sorts of stuff, but as soon as you're in the pond, and you've got to remember we did this in September last year, so we've had barely any time for anything to happen, but a lot has happened. So the water here is just full of plants. We can see stoneworts, lovely sort of floating pondweeds coming up, white flowering ranunculus. So the whole pond is full of thousands and thousands and thousands of plants. And the only way that's happened is because when we've disturbed the sediment here and sort of opened up this pond, the sediments buried under the field are actually full of living seeds. So even though they're buried under a crop, these seeds can still live. So it is genuinely ghostly.
And when about do you think this pond last had water in it? How long have these seeds been waiting dormant?
This pond was marked on a tithe map. And so we think it probably was around about the 1840s. It doesn't appear on any other maps.
Oh, crikey, 150 years?
Yeah, 150 years of probably being lost from the landscape until we brought it back up. So those seeds are very, very old. So I say 150 years, that's the minimum. This could be a very old pond.
Maybe this is rude of me, but it seems like this has been recently excavated. Do you think it will look, I guess, like this for quite a long time? Will it take a long time before it gets back to a fully functioning part of the ecosystem?
Yeah, if I brought you here next year, so you have 2 years of colonisation, it's wild colonisation, you would not know we'd done anything. You would have no concept of this being a field with no pond in it. The pond would be truly back.
I guess then, the idea of, as you said, resurrecting these ghost ponds, that must take quite a lot of the effort out of making new ponds, because you've already got this sort of IKEA ready-made flat pack of a pond ready to spring back to life. It must be quite helpful with the Norfolk Pond project that you're a part of.
So we first of all mapped all the ponds in Norfolk, and then we mapped all the ponds that had been lost. So there's 23,000 ponds that exist, but at least 8,000 to 10,000 that were lost, that are buried. So you can go and dig new ponds, which is great, but why not dig out the old ponds where they used to be, and then you've got this guaranteed wonderful sort of ancient seed bank effect. And the absolute beauty of it is that it brings back species which are incredibly rare in the landscape. So we've had plants come back in ponds that were thought to be extinct in Norfolk, and even a pond in Suffolk where a plant had come back that hadn't been seen in the whole of the British Isles for about 60 years.
What's the plant?
It's a stonework, which is what you're looking at here, a beautiful, elegant stonework called slimy fruited stonewort. Yeah.
It's a good name.
Yeah, but it doesn't sound very nice, but it's absolutely beautiful.
Carl said that during the excavations they found the remains of ice skates fashioned from old bones dating back centuries. He believes this site in the winter would fill with water and cover the surrounding land, and now that the ponds have been restored, it's likely that that old process will begin to happen once again. So armed with all this knowledge, Carl turns to me and says he has a challenge in mind.
What you've got to do now is find your own ghost pond. So let's head back, right, and I'll explain to you how you find one.
Well, I'm never one to back down from a challenge. Plus, unbeknownst to Carl, I actually have friends in the know, ready to assist. Back at Cambridgeshire FWAG head office, Lucy and Wally are waiting bright-eyed and bushy-tailed, particularly, as it might be expected, Wally. Where are we?
We're in here. Right, Harry, take a seat.
Okay, let me get in nice and comfy. What's the plan? What are we doing now?
We're actually just up on the National Library of Scotland website, and you can see on the right-hand side of the screen you've got aerial imagery, modern aerial imagery, and then on the left-hand side of the screen you can select which particular old map you're looking at, and they've got quite a variety here.
Wow, so on the right-hand side, this aerial view looks just like a plane's flown over and taken pictures of the arable land, but on the left-hand side, it's a proper old-school white and black map. This is just taken from 1888.
Yeah, exactly, hand-drawn. So we're looking just north of the village of Winwick in Huntingdonshire. And if you zoom in, here we can see a sort of strange rectangular marking, and you wouldn't necessarily think that was a pond, but what really gives it away is that on the other side of the brook there's a matching rectangle, and we can see on the modern imagery that rectangle corresponds with visible trees and visible dark foliage. So there is likely a sort of damp hollow there, to be honest, because otherwise that vegetation is unlikely to have been allowed to develop.
And if we jump back over to the other side on the aerial image where our potential ghost pond is, it looks just like farmland, but there is, a slight indentation that stands out from the surrounding landscape. It's not entirely visible though, is it? You wouldn't know that anything's there, but we're going to go check it out to see if that has the potential for being an old pond. Great. Off we go then. It's going to be a car trip, is it?
Car trip, yeah, put your wellies on.
Okay, I'll get my wellies on. We're heading back out to Huntingdonshire, near a small village called Great Gidding. That was a lucky little find, that
Yeah.
gap in the hedgerow. You've done this before, Lucy.
Too many times to count, Harrison.
And crikey, it's hard work. We cut across the farmland, battling hedgerows, wading through hip-high thistles, trying to work out exactly how to reach that final desired destination. But finally.
I can see it.
From here?
From here, yeah. There's some slightly taller, slightly greener vegetation that I can see about 150 metres away.
But I didn't see you checking your map. Were you looking at the map?
I was slyly looking at the map, yeah.
Oh, right. On the down low, so I didn't notice.
Well, I was looking at the model. I was on Google Maps and we've got aerial imagery up.
Sure enough, right in the centre of the field, a darker crop rises up out of the farmland. And on closer inspection, it is blatantly obvious that this is the site we're looking for. There's a shallow divot predominantly made up of burnt-looking clay, which we slowly wander and wade over to.
This probably stays really wet, and so
the crop just doesn't take as
come
well.
through. So that's why there's loads of bare soil.
If you do choose to renovate this particular pond, there's a potential that there's water just sitting underneath it, and that it would just rise up quite naturally.
Yeah, absolutely. You know, not just that the water's sitting there, but the seeds are sitting there as well.
And now that we've found this ghost pond, and it actually is a reality, do you think there's a chance that you will renovate this particular project?
Yeah, I mean, I'll have to speak to the landowner. We haven't discussed resurrecting it, but if the right pot of money is there and we kind of fit in with the right project, then potentially it could be a flood mitigation project like we looked at earlier. If it doesn't flood, it could be one of my newt ponds. Who knows?
Well, Lucy, it's been fantastic, the whole experience. Obviously, the examples that we've looked at have been rather industrial on a farming scale. But if it's really piqued somebody's interest who's listening in, and they want to go ahead, they don't have the land perhaps available to them that we've seen, but they've got a bit of space at the end of the garden, is it worth them putting a pond in?
Yeah, absolutely. I mean, ponds don't have to be on the scale that we've been talking about. Any source of clean water that you can get in your garden, absolutely do, because it will bring the wildlife in and they'll find it before you know it.
And Luce, you are the expert. Are there any hints and or tricks that you've picked up over the past few years for building the perfect pond?
Make sure you put it in a nice sunny location. A range of depths across the pond is fantastic, with really nice shallow bank gradients so animals can get in and they can get out. Don't be tempted to fill it with tap water. Let it fill with rainwater, and don't be tempted to plant anything or move any frog spawn or anything like that, because you do risk transferring diseases around. Just let nature take over.
And now you're all clued up. If you end up trying to tackle a bit of land that lies wet and making a feature of it, you know where the expertise is, and do make sure that you keep us updated. Send us a few snaps of your progress to chris@nakedscientist.com, or alternatively, find us on Twitter. Now though, before we go, let's end the show in the usual fashion with our question of the week. James Titko takes stock of what's in the fridge to help with this question that's been sent in by Josie.
Why can't I immediately open my fridge door after closing it? It feels like air pressure is keeping it closed. Is this the case?
With the summer sun heating up the outdoors, I'm relying on my fridge a lot for cool beverages, which is why it's annoying when the door won't budge open after someone else closed it shortly before. Fortunately, Cambridge University's engineering professor Vikram Deshpande is here to explain the science behind this.
Opening of the fridge door will be expected to equalize the pressure inside the fridge with that outside. So it seems counterintuitive that the outside pressure is keeping the fridge door shut. However, closing the door quickly or slamming it shut forces air out of the fridge and lowers the mass of the air inside the fridge. This in turn lowers the pressure inside the fridge compared to the outside, and hence you are correct that air pressure is forcing the fridge door shut immediately after closing it.
So the difference in pressure is what prevents it from opening. But why then does it become easier to open after some time instead of forever keeping it shut?
It takes several minutes for the vacuum or low pressure created by slamming the fridge door shut to be released. This occurs naturally due to small leaks in the fridge seals. And after the vacuum is released, the door is back to normal.
Does this also explain why my freezer door is harder to open than my fridge door?
This is slightly different and actually a great example of what in physics is called Gay-Lussac's law. The law suggests that pressure of gas is related to its temperature when the mass and volume are kept the same. When the freezer door is open, the air pressure and temperature inside the freezer are the same as the outside. But when you shut the door, the freezer cools the air inside, so the molecules in the air vibrate less and exert a lower pressure. Now you have a low pressure inside the freezer and a higher pressure outside the freezer, and the freezer door is shut and it becomes difficult to open. This effect is present in the fridge too, but since the temperature of the freezer is lower than that of the fridge, the pressure difference between the inside and the outside is higher for the freezer compared to the fridge.
So Josie, the reason why fridge doors are difficult to open after immediately shutting them is indeed because of air pressure. Forcing the fridge door shut causes a small vacuum. Thank you to Professor Vikram Deshpande for helping us to find the answer. Next week, we'll be serving you the solution to this brain blast from listener Neil.
Would an explosion on the moon be more powerful than an explosion on the Earth? Thank you.
Thanks for that, Neil. If you've had something pop into your mind recently and thought, you know what, I'd love to get an answer to that, then get in touch with us at chris@nakedscientist.com. And sadly, that's it for today. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Harry Lewis. Thanks for listening. And until next time, goodbye.